In this session, I'm going to solve the problem number 7 in the part A of third semester BSc of Mangalore University. So this is the revised blown up practical list that the Mangalore University has provided. And I'm going to go to the C sharp, that is the problem number 7 in the unit first. So here we are supposed to write a C sharp program to find the addition and multiplication operation on two complex number using operator overloading. I'm going to go to the Visual Studio that is open with me, and I'm going to click on the file menu over here, and I'm going to go to the new, and I'm going to select the project. So once I select the project, I'm going to get many options over here, and you must be specific about whether you are selecting the Visual Basic or F Sharp or C++ or Python or anything for that matter. I'm going to select the C Sharp here. If you click on the Visual Basic, you will find the same option, but all of them are under VB. You notice over here it's going to be VB, but I'm going to select the C Sharp. Under that, I'm going to select the console application. This is the one I'm going to select here, and here you are supposed to give the name for your project. I'm going to say simple complex example. You can give any name, and when you are doing it in your lab, see to it that you store it on a very different location than the location that is specified over here. It may be the colon, or it may be on the network drive or somewhere else. So click on the browse and try to locate the place where you are supposed to store your project as specified by your teacher. Try to do that thing. I'm not going to change it for this demo, and then click on OK button here to continue with the project creation. So once you click on this OK button, Visual Studio will create a sample application for you, and it's going to create the class called as simple complex ex. That is the name that you are given to your it's going to create a namespace called as a simple complex ex. That's the name that you are given to the project, and inside this is going to create a class called as a program, which contains static void main. Now I am going to create a class that will have the complex number being saved. Now before I proceed with the complex number, so what is a complex number? Complex number is a number of this type. So x is equal to a plus bi, where a and b are real numbers. I will take them as integers so that it is easy to look at it, and I is the imaginary constant. So what is the value of I? So I is equal to the square root of -1, which is the imaginary term. For example, you may have something of this type: 5 plus 3i. So this part 3i is the imaginary term, and 5 is the real term. So I'm going to create a class that can hold the value of a real part, that is this 5, and it can also hold the imaginary part, and that is the 3. So two numbers, I will take this as the real part. So this will be my real part, and the other one will be the imaginary part. So one will be the real part and the other one will be the imaginary part. I'm going to create a class that can store it. So how do you create a class? So go to the extreme right side over here. So here you will notice a location called as Solution Explorer. Now what if the Solution Explorer is not shown over here? Suppose if something is not visible on your screen, always go to this menu, that is the view menu. So this view menu will contain all the things that you want to show. If something is not shown, or it will be shown. If something is shown and you don't want it to be shown, then you can go to this view menu. Under this view menu, if you click on it, you get lot of option over here, and all of them are there to either to show or in other words, all of them are there to hide or unhide. Suppose if you are not able to see that solution explorer on the right side, go to the view, and definitely you are going to find this solution explorer. If you click on it, I'm going to minimize and then click on it, it's going to come up over here. That is same if you click on here, one and the same. So either you can go here and then activate the solution explorer, or you can go to this side and activate the solution explorer. Let me look at this solution explorer over here. A lot of things are there. Do not go for the solution, the top side. Go to this one, simple complex example that you have taken. Right click at this point, right click. So at this point, just right click, and you get a lot of option over there. One of the option will be add. Okay, so what I've done is I activated the solution explorer, right click on it, and then go to this add. When you go to this add, you get a lot of options over here, and definitely there is this option that will be available. Class option is directly there. You don't need to click on it. You can directly click on class. Now for some strange reason, which is 99.9%, it is not going to happen. This class is not visible to you for some good reason. I don't know why, but for some good reason, if it is not visible, then go to the new items. So what did you do here is right click on it, go to add, and then you can directly click on class. But if it is not visible, then click on the new item. So when you click on this new item, you will be given an option of adding lot of things. So that is available in C#, and the one that I am going to select is this class. I'll select this class. You can have interface, class, user control, and so on and so forth. So I will select the first option, that is the class. Once you select this class, go down, and it's going to say what is the name of this particular class. I'm going to click on here. Suppose if you delete this CS, it's okay. It will add the CS for you. Even if you delete this CS, it's all right. You just type the name. I'm going to give the name for this class as the complex. That's the name I'm going to give. You can give any other name, but to give a name that makes sense. So I have selected this class and I have given the name as complex. .cs is optional. Even if you don't add it, Visual Studio will add that .cs for you. Then click on this add button. It's going to add the complex number. Now you notice that there are two files are there over here. One is your main program, that is program.cs, but that has a static void main, and the other one is complex.cs. Now by mistake, suppose if you close this one, so for some bad reason you close this one. Okay. So if you close this one, where to find this one? If you close this one, again you can go to this solution explorer over here, and if the solution explorer is not visible, go to the view and click on the solution explorer. Suppose if the solution in the solution explorer, you will notice in the solution explorer, if you click here, you will notice that that class is there, complex.cs. Double click on it and it will come back. Okay, suppose if you close it, go to the solution explorer and double click on it, it's going to come back. Now I'm going to store two things over here. Now I will assume that both the numbers are integer, but you can take it as float. If you take float, zeros will come. It will look a bit kind of bad in the output. That's why I'm doing it as an int. So I'm going to take int, and I will take the real part, that is RP, and the imaginary part, IP. So I'm going to take these two variables, and I'm going to create a constructor for this particular class. So how do you create a constructor? You say public and you say complex. Okay, so public complex, and there is this thing on. Okay. So that I think I thought it is given me the lower bracket, but it has not added. Now this complex will when it is created, I will give two parameters, that is for the constructor, I'm going to give two values. So first one is integer, the real part, and the other one is the imaginary part. So two part I'm going to give it. So when you create a class, I will supply these two values, and the next part that I'm going to do is I have the this dot IP, that is the not IP, the RP real part is equal to the real, and this this dot imaginary part is equal to the img. So what is that I'm doing here is a simple thing. When I create this class, I'm going to supply the real values and imaginary values. These real and imaginary values will be stored in the local variables, and that is the object variables which are available over here, and I'm going to store it in this. Okay, so how do you create a new class? So for example, you can create a complex, suppose if you say complex 3 comma 4, if you do that thing, so 3 and 4 in this case will be supplied. So this 3 will be supplied to the real part, this 4 will be supplied to the imaginary part. This is, you are supplying it from the outside world. These two values will be supplied, and these outside values will be stored in the corresponding variables which are inside this class. In other words, you are going to store those two values from the outside world. You are going to get those two values 3 and 4, and you are going to store them locally within the class. So that is what you are going to do. Okay, now let's look at the other part. Let's try to create the object or the operator overloading. That is what they have said. You are supposed to overload the operator addition and multiplication. So I'm going to say public, okay, static, because it is an operator, static, it must be available at the class level, static. And when you add two complex number, suppose let me show you that particular thing. Suppose if you take two complex number, say let's say you have two numbers, 2 plus 3i, that is one number, and let's say you have one more number over here, that's the other number, let's say 5 plus 6i. So what is the sum of them? The sum of them will be, you are going to add the two numbers, and that is you are going to add these two. 5 plus 2 is 7, plus 6 plus 3 is 9i. So you add the corresponding values, that is the integer, the imaginary terms and the real terms, and you are going to do it. And let me show it one more time if you didn't get that thing. So suppose if you have this number 3 plus 2i and 5 plus 6i, if you add these two numbers, so if you do this particular thing, so if you add this, so first you add this real term, this 5 and 3, that's going to be 8, and then you add the imaginary term, so that is 6 plus 2 is again 8, and you put the 8 in front of it. Now what thing that you are going to notice is, when you add two complex number, the result is also a complex. So what you get is a complex. So this is the additional operator. So when you add two real numbers, you are going to get when you add two complex number, you are going to get a complex number itself. So the return value, of this plus operator is also a complex number. So I'm going to write a public static complex. That reason is because when you use this operator, plus operator, it's going to return a positive value. I'm going to say operator. My WhatsApp is active. Just a minute. I will disable, just 1 minute. I will disable my internet. Okay. So I have this plus operator, and it's going to take two complex number. I'm going to say the first complex number is x, and my second complex number is y. Okay, so I take two complex number. So what is the meaning of this? So if you are not getting this one, what is the meaning of that is you are going to, this is the operator, plus operator, that's the operator that is going to be used for adding two numbers, and you are taking two complex numbers. So let me give you the same thing. 3 plus 2i is the first number, and the second number happens to be 5 plus 6i is the second number. So this first number is this x that you are giving, second number is this y that you are giving, and the operator that you are going to operate on is this plus. So this is the operator, plus operator, that you are going to use for adding two numbers. So that is two complex number, and this first number is x, second number is y. Remember, this is not integer, it is a complex number that has the real part here and the imaginary part here. After addition, you are going to get a answer, and that answer is also a complex number. That is what is being shown there. So it's going to return a complex number. So in other words, when you operate this plus on two complex numbers, namely x and y, you are going to get a complex number altogether. So that is the meaning of it. So now let's go back to the work now. So how do you add the complex number? Let me show it again. I don't know how many times I'm supposed to write this thing. 2 plus 3i. I think the last time I wrote 3 plus 2i. Anyway, 5 plus 6i. So first thing what you are going to do is you are going to add the real part, and you are going to add the imaginary part. So you have to add the real part and you have to add the imaginary part. So how do you go about this one? Let me take the first number here. And what is this first number? First number is x. You have taken this x. X has two parts. One is the real part. What is the real part that you are given to x? Is the number 2. That is the real part of x. And what is the imaginary part of x is 3. So in other words, let me redraw it and show it. So x is nothing but 2 plus 3i. This whole thing is x. Okay, so it contains one real term, and that real term will be stored under rp. That's a real term. Okay, so that you are going to give here. So this is the real term that you are going to give. Also the imaginary one, that imaginary term that you are going to give here, will be stored in this imaginary part. So x contains the real part of x is x dot rp. That is the real part. What is the real part? That is this 2. 2 is x is the variable name, rp is the real. So this is the real part that I am taking. This is the real part that I am taking. Similarly, x dot IP, that is the imaginary term. What is the imaginary term? Imaginary term is this. You have stored it under IP over here. So imaginary term will be IP. In the same way, I also have it for the next number. Suppose the next number is say y is equal to 5 plus 6i. Suppose if I have it there. So y has again same thing. Y has the real term as well as y has the imaginary term. So what is the real term of y? Real term of y is I dot real part. That is the real part of y. I dot imaginary part of y is this one. So real part of is this one, and imaginary part will be this one. And what is that we are supposed to do? We are supposed to add the real part and add the imaginary part. In other words, so when you write the 2 plus 3i. When you write that thing, so what this is your x. So this real part of x will be, this is the real part, 2 is the real part, and the imaginary part will be ip. Okay, in the same way, when you have the y here, so when you have this y is the real part of y is 5, the imaginary part is 6. Okay, 6i. So you are supposed to add the real part of both of them. So you are supposed to add x dot rp plus y dot rp. So what you are supposed to do here is you are supposed to add x dot the real part, that is the real part of x. The real part of the real part of x is this 2. Real part of x is this 2, and you are supposed to add y dot real part, and which is the real part of y. Real part of y is this, and this is the real part of y. So 5 is the real part of y. In the same way, you are supposed to do the x dot imaginary part plus y dot imaginary part. In the same way, you are supposed to get the imaginary part of x and imaginary part of y and add them together. You will get a result. In this case, you are going to get the result. Let's say you are going to get this result. If you get the result 7 plus 9i, suppose if you get this 7 plus 9i, so this part is the 7 is this part, and imaginary part will be this part, that is 9i. Again, this itself is the complex number. Okay, so let me do that thing here. So I will store them in this part now. So how to add the real part of x dot real part, that's the first part, plus y dot real part. This is one term, so not an integer, the real part. What is the second thing that you get? X dot imaginary part, imaginary part, and y dot imaginary part. You get these two. Okay, so this is what you are going to get it. Let me show it one more time. 2 plus 3i, that's the first term, and 5 plus 6i, that's the second term. So this is imaginary part of x, real part of x, real part of y, that you have added. Okay, again imaginary part of x, imaginary part of y, that you have added. Yes. So what is the answer you are going to get? Answer that you are going to get here is 7.9i. You are going to get 7.9i. So this itself is the complex number. So this is one more complex number. Okay, let me call that complex number as a z. So this is a new complex number that you are going to get, that has the real term, that is sum of real term, okay, and the sum of the complex term. So how do I do that thing? Okay, so I'm going to say z is a new complex number. Let me write that complex number first. You get a new complex number called as z. Okay, you get a new complex number called as z. So I'm going to say new complex number. Z is a new complex number with the real term is this, and with the imaginary term as the other term. So this will be the real term, and the other one will be the imaginary term. So I'm going to go over here and let me do it for the last time. So 3 plus 2i is the first term, 5 plus 6i is the second term. When you add them together, you got 8 plus 8i. So this is the sum of real numbers, and that you got it one term. This is one term, and 8 you got it again from the imaginary part. Okay, so these two, this is, suppose if you look at this one, this is one more complex, you get a new complex number. That is what you said, z is a new complex number. You are getting a one more new complex number. Remember, this is a something that returns. You have to return this value. It is not enough if you get this one. You are supposed to return this z back. Okay, now one thing that you will notice over here is that this part is extra. Whether you call it as z, whether you call it as a y, whether you call it as a p, whether it is called a q, it doesn't matter. It's a new complex number that you're going to get. So when you add, in other words, when you add two complex number, you get a new complex number. That's it, you get a new complex number, and you are supposed to return that new complex number. Whether you call it as z, whether it is p, whether it is q, it does not matter. You are supposed to return it back to the caller. So what I'm going to do is I will not give it exclusive name. Instead, I'm going to say return. I'm going to directly write it as return new z. So what is the meaning of this is, what does this mean? This means to say that when you add two complex number, so let me start with the same old thing, 2 plus 3i is the your first number, and 5 plus 6i is your next number. When you add them, you are going to get a new complex number. You get a new complex number and you are going to return it back. That's all. What is the name of it? Whether you call it as z, whether you call it as a, whether you call it as k, doesn't matter. You just return it back. Okay, so that's done. Now we are supposed to write one more method. Okay, and I am going to say public static. Okay, and we are supposed to do the multiplication operator. So to do that, I'm going to go to the Byju's. So this is the Byju's. Okay, so this is the Byju's website, and they have told me how to add to how to multiply two complex numbers. So according to them, how to add two complex number is, suppose if you have two complex number, just imagine you have two complex number a plus bi, and the next one you have one more number c plus di. If you have that thing, so how do you multiply it is, you take the real part a of the first number and you take the real part of the second number, you multiply them together. A of the first number, that is the real part of the first number, real part of the second number, multiply them together, you get the answer, minus imaginary part of the first number and the imaginary part of the second number. So you get this. This is the real term of the new number. This is the real term. That's not the end of it. Now you change your mind, and then now you take the real part of the first number, multiply it with the complex part of the second number. Okay, then you take the complex part of the first number and multiply it with the real part of the second number, add them together. This will be your imaginary term. So this is your imaginary term. So this is how you are supposed to do it. Okay, so first you are going to, what you are going to do in the multiplication is, you are going to take the real part of the first number, multiply it with the real part of the second number, minus imaginary part of the first number, multiply it with the imaginary part of the second number. This will be your real part of the new number, plus now you take the real part of the first, multiply it with the complex, that is imaginary part of the second, you get it here. The complex part of the, that is the imaginary part of the first number, multiply it with the real part of the second number, you get it. You get one more term over here. So this will be your imaginary part, and what you notice here is this is also a complex number. That means to say that when you multiply two complex number, you are going to get a complex number again. So this is what is the whole thing over here. So when you multiply a complex number, you get a complex number altogether. So I have to overload a operator, and what is the name of the operator is star is the name of the operator, and I'm going to say it takes again two complex number has to be multiplied. So you take the first complex number as x, and you take the second complex number as y. So you take that one, and you are supposed to return it back. That is the new complex number. So how do you go about doing it? Okay, so let's do that thing. So what is that you are supposed to do? The real part of the first number, look at what they have done. A real part of the first number is multiplied with the real part of the second number. So let me do that thing. So real part of the x is see, x is the complex number, remember, as in the previous case, x is the complex number, into real part of the second number. So this is the real part of the first with the real part of the second, minus complex part, that is the imaginary part of the second number, that is first number, into imaginary part of the second number. So what is that I have written? What is that I have written is let me slightly get it down, and let me scroll it up over here. I hope you will be able to see this thing. I will scroll it slightly up. So what is that I have done? So let me slightly go here and let get my Visual Studio slightly down. So what is that I have done? A real part of the first number, that is your x is your first number. Look at this, x is your first number. So real part of x into the real part of y. Y is your second number, real part of y. So this part, this whole thing is that part. Minus imaginary part of first number. So first number is x here, imaginary part of x is this one, into imaginary part of the second number. So that is this. This is the one term. This is one term that you are getting. What about the second term? The second term is okay, real part of the first number. Our number is x here, x real part, into the imaginary part of the second number. So second number in our case is y, y imaginary part, okay, plus imaginary part of the first number. So first number is x here, imaginary part of the first number, into imaginary part of the first number, into the real part of the second number, the real part of the second number. So y real part. So this is 1. And what you are going to get? You are going to get one more. Remember, this is also, this is the real part, this is the imaginary part. You are going to get one more complex number. In other words, when you multiply two complex numbers, you are going to get one more complex number. You are going to get a new complex number. So how do I say that thing to my C#? To my C#, I am going to say when you multiply this two complex number, you are going to get a new complex number with these terms. This is the first term, this is the second term. To make you understand the content, like how our Byju's people have done, they have put the bracket so that it is easy to view. There is no need for you to do that. C# can get all your complex things, but to make it look neat, this is not 0, sorry. This is the first term. So how they have put, see this open bracket and close bracket. How I have also done the same thing. How this Byju's people have done, I have also done that thing. Also, I have done this part, so that it looks neat. So how they have done it, not because they have done, I am doing it. It looks neat. Okay, so that is it. And what is that you are supposed to do? You cannot keep it with yourself. Return it back to the caller. Whoever has called this thing, you return it back. Okay, so that you have done. Okay, now I think I can override one method, public, where is this override ToString method. Now I will tell you what is this ToString method. See, whenever you want to just call, if you just say, now in your I will give you an example of your C program. So you say print f and say percentage d and then say x. Now it's going to return the value of x. It's going to print the value 5, 6, 7. You've done the, you've seen this in your C program. In the same way, suppose this printf function is not there. Don't get confused. Here I'm not going to use the printf. Suppose if you say printf, the first complex number, that in my case the complex number is x. Suppose if I say to the printf, okay, you print the complex number, how is it going to print? That question is going to come. Why? Because see, 5 is just one number, but x is not one number. There are two parts are there for the x. One is the real part is there, other one is the imaginary part is there. How do you look at the complex number? So x is equal to 2 plus 3i. It should come like this. Then okay, the real part must come, the imaginary part must come. So whenever I say print this value, it should come like this. So I want it to look like that. So how do I do that thing? So for that I am going to override this ToString method. So how do I do that thing is, I'm going to say string and I'm going to say format, okay, and I am going to say this one. So this is my first number, this is my first number, plus this will be my second number. After that I want I. So let me just look at just a minute. So this is how I want it to come. This is my first number, plus must come, and this is my second number, then I must come. So look at how I have done that. This is my first number, whatever number, okay. So this is identical to your percentage d in your C program. So this is also equivalent to percentage d in your C program. Okay, so don't get confused. So this is first number, this will be the second number. In between them there is this plus symbol, after this second number you have this I. That is what I'm showing it. So it should look like that. Okay, so this is what now I am not done. Now what is this first number? That part I have to tell. What is this first number? First number is the real part, second number is the imaginary part. So if you write like this, 2 plus 3i, what is the this part? This is the real part, this one is the imaginary part. So you have to say here, it's not enough if you say this 0 and 1. 0 is the real part, the other one is the imaginary part. So real part will come here, whatever value in the real part will come in this place, whatever value which is there in the imaginary part will come here. So both will come at these two locations. So this is what you have done. So with that, your class creation is over. So let's go to the other part. I'm going to just get it over here. Let's go to the other part again. So this is your class part is over. If you want, you can save everything. Let's click on this program. Now by mistake, if you have closed this program, go to the solution explorer and you will find that program.cs. Just double click on it and you get this static void main class. So go here and let me create two variables. Okay, so let me create two variables of type complex. So complex is my class. And I am going to take two variables, m, n, two variables, and I am also going to take two integer variables. This is just for my calculation. I will not be using it for anything. One is the real part and the other one is the imaginary part. I will not type it again. So I have just taken it. So these are integer. Remember this, don't get confused. This is an integer. The other two are complex number. So let's accept the two numbers. So for that I'm going to say console. I think you can say console cr double tab. Okay, so that is not the console. Console dot I think this not R sorry CW and double tab, it's going to say console dot write line. Okay. So I'm going to say here is enter the value of first complex number. This is what I'm going to say, and that's not enough. I'm doing it a bit neat. Then I'm going to say CW and double tap. Now I don't want right line there. Right line means it's going to go to the next line. Right means it is going to stay at the same line. So that is it. So I'm going to go over here and I'm going to say real part, okay, of the first number, and I'm going to read that real part. How do you get this real part? Real is equal to console dot read line. I'm going to go for the read line. Okay, whatever you read is going to be in the text format. So I will go to the int. Remember, you are reading a line. What is the meaning of that? Is you are reading a text. Suppose if you type the number 5 here. Oh, sorry, I think I typed something else. Okay. Suppose if you type this number 5, this when you say read line, 5 is not taken as integer. Instead, it will put 2. Instead, it is considered as like this. It's considered as a string, not a number, because you are reading a line. So you have to convert this 5 into integer 5. How do I do that thing? I will say int dot parse. Okay, and I'm going to say read this one. So whatever I'm reading from the keyboard, so whatever I read from the keyboard, that is read line. I convert it into integer and I'm going to store it in the integer variable. That's why I created that real and imaginary part. Okay, then again I will not retype it. I'm going to just copy this thing and I'm going to say, okay, and I'm going to say imaginary part, and I will read it from the console and I'm going to store it in the img. Okay, now in your C, you had this get ch. You used to write this get ch in C. Okay, what is the equivalent of that in your C sharp? In your C sharp, you say console dot read key. You see that read key. It's a function read key. It's going to stop at the end if you want. Like how you have this get ch, right at the end you write this get ch. That way, if you want, you just say console.read key. I'm going to just run this one. I am not doing any calculation, and I just want to show you what it's going to show. So when you run this particular thing, it's going to build the C# project for you. My machine is a bit slow and it is also recording, so have patience, and it's going to come, and if there is an error, definitely I get one nasty error message. Now when I run this, hopefully there is no error. When I run this one, you see how is it going to appear. So let me show that thing. I don't want all these things to be clutter the screen. Just to show you how is it going to write. See this, the first thing that you got here, console.writeLine, enter the value of first complex number, and that is this whole thing will come here. Because it is the right line, it will immediately go to the next line. So when you say right line, the cursor will go to the next line. In the next line, what you have is the real part. But I wrote right. Because I wrote right, it's going to stop. If I say right line, it will go to the next line and you will see the blinking cursor down here. Now whatever value I am going to type here, it will be read by this. So it is now this read line, it is waiting for my answer. Suppose if I write 3 here, I have not pressed enter, so this 3 is in the string format. It will be converted into integer and it will be stored in the real. So that is done. After that, so this 3 whatever you have is stored in this real part over here, and the next line is this console dot again write, not right line. So next line it's showing imaginary. I think my spelling is proper. If not, I will go to English department and learn English. In any case, this hopefully that spelling is proper. Imaginary part is been shown over here, and it is waiting for this console dot read line. Suppose if you write 2 here, This 2 will be read by this console.writeLine, converted into integer, and it will be stored in the imaginary part. That will be your first number. After that, it is going to wait again because you have this read key. This is same as get ch, and if you just press, it's going to go. Now I got the real part, I got the imaginary part. I'm going to create a first number. My first complex number is m here, so I'm going to say m is equal to, I'm going to create a new complex number with the value in real part and the imaginary part. So I created new, so whatever real part I am reading here and the imaginary part, I got it. Okay, now I don't have to write it again and again. In your, when you are using this Turbo C, which is a very old outdated software, you had no chance of copy pasting it, but when you are using the C Sharp, you have an option for copy pasting, because Visual Studio is a wonderful IDE and you can do wonders with that. Okay, so I'm going to copy this whole thing, Control C to copy and Control V to paste. Okay, so whole thing is pasted, and only thing I'm going to say, enter the value of second complex number, and the real part I am reading it, complex part I am reading it. There is nothing new. The first complex number was m, second complex number is n, and I'm going to say this is my second complex number n. I got this one. Okay, now I am going to add two complex number and I'm going to put the output here. So I'm going to say console.writeLine and two tabs for that. So how do you add two complex number? So to add, this is my first complex number. So it is like %d plus %d in your C program, but here we are writing like this in a flower bracket. Is equal to, in your C program also you used to write like this, %d plus %d is equal to %d, but here we are just giving 1 2 3 as a placeholder. So what must come in the first number? First number is my m, is my first number, first complex number is this m. Second complex number will be n, and the final complex number will be m plus n. That is the answer that I am supposed to get it. Okay, so sorry, this is not 3, so I think now I have to start learning mathematics. So this is 2. Okay, 0 1 2, the placeholder. Just to give it a try, what is there? So let's see whether we are getting the first number. So the first number is, let me zoom in for you if you are not able to see. First number is 2 plus 3i, that's the first number, and the second number is 5 plus 6i, that's the second number. And what is that you are expecting? You are expecting this 2 plus 3i plus 5 plus 6i is equal to 2 plus 3, this is the real part, 2 plus 5 is 7, 3 plus 6 is 9, you are getting it. Make it a bit beautiful, like how these Byju's people have done. Let's do that thing. So how do I do that thing? Let me zoom out and let me do that. Okay, so I will put okay here. Remember, this is not required. If you are getting confused, don't do it in the examination. I want to how these Byju's people have done. So again, am I advertising this Byju's now? They have not paid me, by the way. So this is just a bracket. See, let me show it again. Let me take you to their site now. See how beautiful they are doing it. They put it in a bracket, so it looks nice. That's why I'm doing it. So I'm just covering this 1 2 3 with the bracket. Without bracket also it's going to work, so that it will come like this. The numbers will come inside this bracket. So it looks nice. Okay, so I feel like it looks nice. If it's not looking nice for you, you don't add it. And by the way, my personal suggestion is, don't go, if you don't get this story, don't add it. You are going to get it. Your external examiner who is coming for you, they know it, what is the answer. Okay, so let me run it and let me show you. So again, so see whether it is 2 is the first number, that is real part, 3 is the imaginary part. So this is 2 plus 3i, and I said 5 plus 6i, and how am I getting it? So am I getting it beautiful? See, 2 plus 3i plus 5 plus 6i is equal to 7 plus 9i. So what is that I have done is, let me take it here. Let me take it here. Okay, where is that? What is that I have done is, there is nothing much I have done. I have put a flower bracket. So just a flower bracket, sorry, what do you call it as? The circular bracket. I put this circular bracket and it looks neat. I put a circular bracket and it looks neat. I put a circular bracket and it looks neat. That's what I have done. Is it part of the program? It is not. It is just make it beautiful, and there are some external examiners who are a bit sensitive, and they say would you get a neat output. In that case, it is better you do it. People like me are happy with the thing as long as the computer the answer is proper. The second part is you multiply it. So you multiply it. So this is multiply, and this is when you multiply, you have to multiply. So that's it. You multiply it. Give it a try, and you must get the answer. So let's say the first number is what is it, 2, second number is 3. This is 2 plus 3i and 5 plus 6i. You multiply it, you must get, you multiply and find out for yourself. By the way, I think the Byju's have the unsolved problem was there. It's just saw, but it is giving me the negative numbers. So do you have? Oh, okay, see there. Okay, so 6 minus 4i. See this? They have one complex number. Let me try that itself. So I'm going to run my program. Run, please. And I am going to type the value that Byju's people have given. And I want to get this number according to Byju's. That is the additional part. You know very well, there is nothing much to be done. So this is 6. This is 6 minus 5i. So minus 5. That's it. First number. Second number is 3 plus 7. So 3 is real part and 7 is the imaginary part. According to Byju's, see, remember, don't worry about the additional part. Multiplication part is, according to them, it is 53 plus 27i. Am I getting 53 plus 27i? If that satisfies you, that's all in this video. We will meet again in the next class. Thank you.